have your chapter 13 packet out. We are currently on page 7. At the bottom of page 7, we're going to quickly discuss what we learned in geometry last year for right triangle trig. So we reviewed that sine on a right triangle referred to sine of the angle position is equal to the opposite over the hypotenuse. So ka toa. And that's what we learned in SLGO for the relationship between the legs and the hypotenuse of a right triangle, and then the angle measurement from which we are positioned. So as we look at that triangle and superimpose, say I'm going to go ahead and highlight this triangle. So if you want to picture this triangle, now right here, where the coordinate point, any coordinate point on the circle is defined as x comma y, and the circle with a radius of r would then be, if I had to find the distance between the origin and any point on the circle, using the distance formula or Pythagorean theorem, I'd find that r is equal to the square root of x squared plus y squared. Now, if I define r with a value of 1, that's called the unit circle. So what you want to picture is if r was equal to 1, how those relationships would relate to the relationships that we see up above here. So on page 8 at the very top, I'm going to first set up my trig ratios according to the values that I see on here, as opposed to using O, A, and H. We're going to redefine it using x, y, and r. So if sine is opposite over hypotenuse from this angle here, from theta, opposite value would be y, and then the hypotenuse would be r. If I'm standing there, the cosine would be x over r. Okay, so that's where I'm going to pull the values. So let's go ahead and record those values on the next page. So sine of theta would be y over r, opposite over hypotenuse. Cosine of theta would be x over r. Tangent of theta would be opposite over adjacent, so y over x. Now on a unit circle, if we redefine that and say, what if the radius is equal to 1? How would those trig ratios change? Well, then sine of theta, if I'm plugging in a 1 for r, then my sine of theta would just simply be the y value. If I plugged in 1 for r on cosine, cosine would be x. If I plugged in r equals 1 into tangent, doesn't affect it because there is no, tangent isn't defined by the radius value, so y over x. So these are going to be crucial going forward, that you understand on a unit circle, sine is simply the y value, cosine is the x value, and tangent is y over x. So now, taking a look at example number 1 below there, now you're given certain values for x and y. So we're given that this coordinate point is the x value is positive 4, the y value is negative 3, given by these values here. And then the radius is 5. So we see that we don't know the sine, cosine, tangent of the angle, and the angle is going to be the initial side being right here, and then it's always formed by the x-axis and then the terminal side. Okay, so now if I want to set up the sine, cosine, and tangent of that angle, we don't know what that angle is, so I'm just going to go ahead and define it as sine of theta. And then according to the above, sine of theta is equal to y over r. So let's go ahead and put y as negative 3 over r would be 5. Cosine of theta would be adjacent 4 over 5. And lastly, tangent of theta is y over x. So y being negative 3 over x, which is 4. Okay, so You notice that if sine and cosine are defined by the values that you have for y and x and r, we want to consider, well, within each quadrant, what are the signs of y, x, and r? Well, the radius of any circle is always positive. So the values that you remember from just a normal typical xy coordinate point in the Cartesian coordinate point would indicate that you have this is x is positive here, y is positive, x is negative in this quadrant, quadrant 2, y is positive. In the third quadrant, both are negative, and in the fourth quadrant, positive, negative. Now, because of the fact that those three trig functions are dependent on those values, as well as r, with r always being positive, there's a little acronym that a lot of students use to remember whether sine or cosine is positive or tangent is positive in those quadrants. And so in this quadrant, I'm going to go ahead and write the letters out. A, S, T, C. And the acronym that you're going to use to remember that is all. I'll write the acronyms above here. All students take calculus. So the A, the S, the T, and the C, first letters of all of the words in that acronym, simply stands for all trig functions. All trig functions are positive in the first quadrant. And that makes sense. Both x and y are positive. So all trig functions are positive. The S stands for which trig function starts with an S. Sine is positive. And since sine is the y value, it makes sense that y is positive in that quadrant. That means cosine is negative and tangent is negative because tangent is based off of x and y. And since they're both opposite signs, having a ratio of a positive and a negative is going to yield a negative solution. So T stands for which trig function is T? Tangent. Okay, so tangent is positive in the third quadrant. That makes sense. A negative over negative is positive. And then finally C stands for cosine. And cosine is positive in the fourth quadrant because x is positive. Okay, so I am now going to stop the video and then have you guys watch a brief video on reference angles, and then we'll follow that up with the